Friends, this spoken tutorial is on orthographic projection of a point in first quadrant. In this spoken tutorial, we will visualize position of a point in 3 dimensions by the help of a 3D AutoCAD model and develop rules for 2D drafting from 3D visualization. And finally, we will draw on the paper orthographic projection for a point in first quadrant. Prerequisites for understanding this spoken tutorial are a thorough understanding of basic concepts of orthographic projection, quadrant, vertical reference plane, horizontal reference plane, and side reference plane, front view, top view and side view, horizontal reference line and side reference line. Watching the video orthographic projection and solved question on YouTube Khabia search channel will be of help in developing the necessary prerequisites for understanding this spoken tutorial. Let us now start understanding the concepts of orthographic projection of point in first quadrant by the help of a question. The question is, a point A is 30 mm above HP and 50 mm in front of VP. Draw front view, top view and left side view of the point A. Let us first understand the 3D position of point relative to quadrant by the help of 3D model shown. In this 3D model, point A is kept exactly as mentioned in the question. Let us understand the 3D model from starting so that a little revision of basics is also done. This blue colored plane is called the vertical reference plane. This yellow colored plane is called the horizontal reference plane. Horizontal reference plane and vertical reference plane are mutually perpendicular to each other and both combined constitute quadrant. The line of intersection of horizontal reference plane and vertical reference plane is the line XY, and this line is called horizontal reference line. This arrow indicates front direction of looking and this arrow indicates top direction of looking. The region of space above HP and in front of VP is called first quadrant. The center of this green colored sphere represents the point A. In the problem, we were asked to keep point A 30 mm above HP, and you can observe from the model that in 3 dimensions point A is kept exactly 30 mm above HP. In the problem, we were asked to keep point A 50 mm in front of VP, and in this 3D model also we have kept point A exactly 50 mm in front of VP. To obtain front view of point A, we draw projector from the point A perpendicular to vertical reference plane, and this projector intersects the vertical reference plane at A dash, and A dash is the front view of the point A. You clearly observe that distance by which front view is above the reference line is equal to distance by which point A is above HP. That is, front view A dash is 30 mm above the reference line because point A is 30 mm above HP. To obtain top view of point A, we draw projector from point A perpendicular to the horizontal reference plane. This projector intersects the horizontal reference plane at the point small a, and this is the top view of the point A. From the 3D model, you can easily conclude that distance of top view of point A from reference line is equal to distance of point A from VP. In other words, you can say that top view is 50 millimeter in front of reference line because point A is 50 millimeter in front of VP. To draw on paper, we open the quadrant. The rule for opening the quadrant is always open the first quadrant. We keep VP fixed and revolve HP by 90 degree so that portion of HP in front of VP comes down and portion of HP behind VP goes up. Let me now open the quadrant before you so that the concept of opening the quadrant becomes very clear in your brain. To open the quadrant, we keep VP fixed and revolve HP by 90 degree so that portion of HP in front of VP comes below the reference line and portion of HP behind VP goes above the reference line. I have opened the quadrant and you can clearly see that top view has come 50 millimeter below the reference line because point A was 50 millimeter in front of VP. Now let us start thinking about the left side view. To obtain the left side view of the point A, you simply look at the point from left side like this. And you take projections on a side reference plane which is perpendicular to vertical reference plane as well as horizontal reference plane. It is to be noted that side reference plane is kept towards right side of the point because in first angle projection system, object lies between the observer and opaque reference plane. When observer is looking at the object from left side, naturally the opaque side reference plane goes towards the right side of the object. From this 3D model, you can easily reason out following conclusions about the side view of the point. First conclusion is distance by which side view is above the horizontal plane is equal to distance by which point is above the horizontal plane is equal to distance by which front view of the point is above the horizontal reference line. Second conclusion is distance of side view from side reference line is equal to distance of point from VP is equal to distance of top view from horizontal reference line. Let us now start drawing the orthographic projection on paper. First, draw horizontal reference line XY. Then draw projector for the front view of point A perpendicular to the horizontal reference line XY. Front view of point A is 3 cm above the reference line because in 3 dimensions point A is 3 cm above the horizontal reference plane. Naming of front view is done in small letters with a dash. In this 3D model also you can observe that front view A dash of the point A is 30 mm above the reference line because point A is 30 mm above HP. Now we will make the top view of the point, and the concept is distance of top view from horizontal reference line will be equal to distance of point from VP equal to 50 mm. To obtain top view of the point, draw projector from the front view A dash perpendicular to reference line. Top view will be 50 mm below the reference line because in 3 dimensions point A was 50 mm in front of VP. Naming of top view will be done in small letters without dash. Another name for top view is plan. And another name for front view is elevation. Now let us try to make the side view of the point. First, we draw side reference line perpendicular to horizontal reference line. Question arises, by what distance side reference line x1, y1 will be towards the right side of front view. And the reasoning comes out from the 3D model. If you look at this 3D model carefully, then you see that distance of side reference line x1, y1 from front view A dash is equal to distance between side reference plane and point A. Since in the question distance of point A from the side reference plane is not given, we will take the distance of side reference line x1, y1 from front view A dash, any convenient distance. Now let us understand the opening of side reference plane. Side reference plane is always opened about VP such that level of side view is same as level of front view. Let me open the side reference plane before you so that you get a clear visualization of opening of side reference plane in 3 dimensions. In 3 dimensions, side reference plane is opened about VP like this. And you can clearly observe that level of side view is same as level of front view. Distance by which side view is above the horizontal reference line is equal to distance by which front view is above the horizontal reference line is equal to distance by which point is above the horizontal reference plane. On paper, draw projector from front view A dash parallel to horizontal reference line and side view will lie on this projector. Second concept is what will be the distance of side view from side reference line. From 3D model it is very clear that distance of side view from side reference line is equal to distance by which point is in front of VP is equal to distance by which top view of point is in front of reference line. In other words, you can say that distance of side view from side reference line is equal to 50 mm because distance of point from VP is 50 mm and because top view is at a distance of 50 mm from horizontal reference line. Construction method for making the distance of side view from side reference line x1, y1 equal to distance of top view from horizontal reference line xy is as follows. Draw projector from top view parallel to horizontal reference line. Keep compass pin on point of intersection of horizontal reference line and side reference line and mark a quarter circle like this and then draw a vertical projector. Intersection point is A double dash and this is the side view of the point. More correctly, this is the left side view of the point. I hope this 3D model was successful in fixing 3D concepts required for making orthographic projections of point in first quadrant. Thank you for watching the video.